Is that a bit better? Maybe, maybe not. I don't know. Seems a little bit dark. Is that a bit brighter? Like over here. That doesn't really matter. You're not looking at me. You're looking at the code. Okay, so here's Claude Code doing its thing. Now, the reason I'm recording this is because today we have been working since 9 o'clock. It is now nearly 8 o'clock, so it's 11 hours with a break in there that was maybe an hour. Okay. So far, 8 hours. And what have we done today? And what's it doing right now? Let's start with that. What's it doing right now? What it's doing is it's doing the final touches of music's good, but I don't know how interfering it is. What it's doing, oops, still needs me to give the old coding pigeon, pop, pop. Even though, as you can see, it's on auto accept edits. Okay, so started off today with this notion of okay, what did it? Hacking code. Okay, so for the last 2 days, I've been asking for it to create the concerns since Monday. This is now Wednesday, I think, isn't it? No, it's only Tuesday. So I started, I think, this on Sunday. And then yesterday we did the concerns. And 2 times, it's been not great. And it's got confused. And then it's just kind of, we just end up just like, okay, let's not do this. Let's not commit. Let's not, what is it, merge or something. So, the concerns is basically the sensitive system for the, basically it's the hermit crab locus 3. So it's around the kernel and the shell. That structure is in a kind of fragmented state of loopness. Okay, so it might be listening to something that's on the internet. It might be waiting for the user to put some text in. It might be kind of waiting for a cron job to and to fire, and then it does something. Like, for example, do a review every day or every 15 minutes, go, like, is everything okay? Is it healthy? Am I okay? So that's the thing. That kind of loop process was created by, that's what made the malt crab, the original open claw or whatever it's called, right? It's this idea that it's got these kind of loops, which is nothing new really, but our version of it is just slightly different. Okay, because everything that we do is slightly different. And it was, as usual, attempting to do it in the usual way. And of course, I'm fighting that because I'm saying we've got this P scale, we've got like JSON blocks, and these are different. And it influences the LLM in a different way. So the LLM can maybe see this and got a reflexive spindle. So it can tell where it is in all the instances that it's existing in. And therefore, it starts to reason potentially with the ability to inform the next instance. Okay, and so we call that, that's relatively easy, but to do it in a certain way, we call it the Mobius twist, because it's using its internal logic of reasoning. That's for the LLM thinking. Right, so today was quite interesting because it was like, okay, look, can we do this concern structure in a way which, and I haven't made a note of it fully, but basically it changes how code works. So I've been falling into the trap because of Claude Code of creating labels and then code to get information and then do something, get information and then do something. And the loops are all fixed in the kernel. And I was like, okay, why isn't that part of the wake, all right, block? Why isn't that part of a spindle? Because it's literally the right structure for it, I think. Anyway, so we managed to do it today, the first version. And I was like, right, so is it doing this? And I went, no. I was like, oh, for crying out loud. What was that yesterday? It was like, what is the point? We yab about it, we get this understanding. After halfway through one of these sessions, every single time you run these things with sessions, it's like, oh, I'm starting to get an idea of how this works. Okay, it's right. And so today was similar. And anyway, so worked for 5 hours and then restructured the primary BSP. Okay. In order, and what that did is that it means that Claude Code has internalized the BSP function, so it can basically trigger the BSP function by itself. It's still ever so often, or used to, like ask me, and I had to let, okay, yes, do it. And it just means that it can actually do the thing that the LLM instance will do. It performs the BSP function on the actual like code blocks, the JSON blocks. And now Claude Code does it. And Claude, I literally got Claude to code it for itself, so it could do it by itself. So it gives an insight to how it operates. And then I would ask it, okay, so how did that feel? How did the process go? Oh yeah, it's way better. Okay. And because it's got that internal experience of the function, and then it's using it, then it has a slightly different understanding of what it's building. And everything that we're building is external. Okay, it's external. And all code is external. Whereas because we have an internal semantic number where the semantics is inside the number, it means that all the functions and how we use it are different. So it's basically interfacing a traditional LLM, Claude Code, that uses traditional code because it's been trained on it. And then it's got this new system, which we're attempting, it's like chicken and egg. And we're trying to create this thing, but it's using the traditional method all the time. And so it's like this kind of swimming against the current. Anyway, eventually this thing works out. Well, kind of. And eventually it comes up with these insights. In fact, that's kind of useful. It comes up with these insights like, this is quite, oh, Jesus. Okay, okay, and just to give you an idea, it actually died on me. Okay, I'll show you that, all right? The previous version that created the first concern process, that was different. So basically, it comes up with this analysis. So I had this discussion. And it's to do with how it interfaces with the user. And it kind of keeps on thinking that the user is really important. I'm like, the user is just one aspect of the interaction this thing's having. So, And then it's about the purpose block and how it all fits together. It kind of has to sit there and work it all out. It's looking at the architecture, trying to work it out. And I've come up with ideas and I think I know what I'm doing. No, okay, it's earlier than that. There you go. I've been fighting CC to implement every step of the way. Use traditional coding, just what I'm saying to you. Whereas what we're trying to do is this thing in the previous CC that managed to get it up to this halfway point. The P-scale JSON block is the programming language, not a configuring format for a JavaScript kernel. The actual programming language. The kernel shrinks to a spindle walker, given a concern of blocks the address extracts, right? So the spec in light of this, which the overlaps loops. Okay, so I'm basically saying make the jumps to maximizing the semantic number fundamental. So basically this thing understood what it thought it was. I gave it this document which tries to carry on from what was done before. And it's like, it's like diving into a new stream again. And I have to go against it for a while. And then it basically, it comes up with an interpretation, which is interesting. Okay. Instead of doing a loop 2 and wake 2, okay, and you'll see towards the end of this, that's exactly what it was doing still. The kernel runs the phase space. phase. Okay, so we started introducing, and I came up with this brilliant idea. Not a brilliant idea. I saw something. I was flicking through something, and I saw a Fourier transform, and I went, "That's what it is." And I've noticed the Fourier transform a few times in my life, and I just don't quite understand it quite conceptually, but it's very useful, and it's the basis of most. No, I wouldn't say most. It's the basis of quite a lot of LLM processes, Fourier transform, and the creation of tensors, I think. And I thought, oh, could we use a Fourier transform, even though I don't quite know what it is mathematically? And it says, yeah, I think so. I think we can use it. But it's still using labels, and it's still not quite mentioning this Fourier transform. So then it goes, okay, oh, right, that's what you're talking about. That's why you're talking about a Fourier transform. So basically, I'm kind of saying, this is how you're normally working. Yeah. But look, Fourier transform. How about that? And then it goes, and it connects it up. And then it goes, oh, yeah, okay, get you. Now I understand, or it synthesizes a way of doing something. And that's all we're doing with LLMs. We're basically just pointing at a couple of things and putting them together. And of course, nowadays, this year, they're building systems that basically do that go out, connect things up, and then come out with results without actually human beings having to present them with it. And it kind of cuts the human beings out of the loop. And it starts getting a little bit kind of like crazy. And that's what's going to be happening over this year and next year. That's just for front edge research with maths or anything, but also just business. And what I realized earlier today was that, or yesterday maybe, is that we're creating a general purpose agent, like they have. The reason why, anyway, I think I talked about this another time. It's to do with, it's like a robot, basically, an android robot, so it can do everything. So we want a general purpose agent that can basically fit into any human virtual work thing. The kernel Facebook is genuinely just about 10 lines. Look at that. So the kernel Facebook is genuinely, I'm just going to quote that back to it. That's the one. Okay, so the forward transformation. So it basically does this thing, and it kind of understood stuff. It just came up with, I'm going to maybe quote this whole thing back to itself. And then, okay, so it came up with the turning point like the previous one had. Okay, and okay, let's put this down there. Again, encode. Just check what you've done. Plan your the actual code base, your plan, your original mindset. Is it aligned? Have we done what we set out to do? I won't hit yet because I haven't seen what's actually written. So basically it has a turn of mind, okay, and it goes, okay, maybe we can do this. It's like, yeah, okay, good, right? So can you make a note of that? And then it tries to go ahead, make a note, and then hopefully I can refer to this thing that it's kind of like, because when it does a compression, sometimes it loses vital context. And so I need to kind of bring it in. So I'm putting it as a recipe in the cook block, not only for this LLM, but for an LLM that's a hermit crab within the hermit crab. And it goes, okay, how do I do this? And it's about Fourier things and this, that, and the next thing, okay, so I understand that's what it was trying to do. And then it's kind of looking around the actual process it's in. and it kind of can see what it's attempting to do, and then hopefully it can modify itself. Okay, so that was all that. Gets various things wrong, and then I get it to do it right. So it's just different. So, and we basically creates it. It creates the concern block. So we've created a concern block. And then there's a little bit of humming and hang about how we go forwards. Can it create its own concern? It's like, yeah, it should be able to. Okay, wait a minute, I have to fiddle about with something. Oh, okay, right. So hopefully the LLM could create its own concern. And then it was like, okay, so give me, I still, this is now at a level where I'm like, okay, is this thing working? I can't tell. I'm not even looking at the code, all right? So I'm like, I've conceptually understood it. It says it's done it, and it says it's solid. So it's like you build the plane, okay, and then you're right. Okay, so how are we going to test this thing? You basically have to get in it and then, take off. And I haven't put an LLM into it yet. I haven't fired it up yet because I'm just like, okay, are we sure that you've got the right wings? Have we got the right number of wings? Is the thing balanced well? Is there enough power in this thing for it to work? It's kind of like that. Okay, so then it's like, okay, so how is this thing actually seeing this? And it's saying things. I don't like the fact that there are two processes of concern for concern. And why has it got two? And it says, oh yeah, you're right. Okay, you're right. Okay, there's no overlap. Okay, so let's combine them. Let's get rid of wake 2 as one of them. Let's keep both and do something like that. Let's merge them into the wake. It's like, that could work. So it's either A or C. It's recommending A. It's like, okay. But then it's asking me a question. Do you want me to do this? And I'm like, resolves naturally. A user engagement concern updates if the user hasn't spoken for an hour. And you're like, so what do I have to do here exactly? Read the concern block, replace the formatted text. User inputs and signals become concerns, just like heartbeat. And it's got last stamps and stuff. I'm like, and then it's asking me a question about, is that okay? Yeah, add user engagement as concern instances. And I'm like, and I should just go, okay, yes, do it. But I'm just like, wait a minute, why is it doing that? So I have to kind of just observe, wait a minute, what's going on? Are you doing this right? Has it been coded right? I'm sure that's what the whole thing was meant to be. So it goes, oh yeah, okay, let me actually check what the original design was. And then it says, okay, I found, this was the original idea, this is what we were designing. It says all this. So actually, all we need are these four changes. I'm just like, every single time it's like swimming up, against the current. It's like, it managed to get an insight into how to do it. It starts doing it, and then it ends up doing it, and then you go, right, okay, so is that done? It's done. And then you're okay, right. Well, but it doesn't seem to do that. Oh, okay, we'll add some more because it's traditional coding in some form. Oh, let's just add some more blocks. And it's like, no, wait a minute. What did you actually set out to do? And it was, oh yeah, we've actually done most of that. Right. Okay, this is Claude code. This is Opus 4.6. It's amazing, but it's making it's just losing the track. Okay, and what we want is we want to have a method where the LLM can keep track of it logarithmically. Okay, now, I don't know if it's going to work, okay, but basically it's responsible for keeping track of things. And right now, it's kind of cobbled together. Okay, Claude code is a cobbling together of various processes, really good processes, but it's still got compression. And if you looked at a compression, I don't want to fiddle about with it. And you look at a compression file, and basically it's just like it's just got a skill that just says, right, see all this crap that you've got? Okay, answer these questions. What's the history? What's the problem you're trying to solve? What are the critical things? And it's basically just does this, and it goes, okay, it's not compression. It's just kind of coming up with a bloody great big file. But that file is smaller than the massive context that it's been containing. But in that process, obviously, it's losing information because it's just translation. Okay, it's just like just shove it through an LLM itself and just try to summarize it. Okay, whereas our system it's lossless. It's lossless. Okay, so it's just about how much focus or generality it's kind of manipulating. And if it really needs to find something, it goes, okay, I found, that's the thing. Okay, and the order of priority that it's got, it's creating itself logarithmically as it goes along. Okay, so if it's reduced the importance of something and it's deprioritized it, and then it's like, oh, wait a minute, I need to kind of like focus in on that again, it can find that information and expand it in its kind of awareness bubble. It's not an awareness bubble, it's in its context window, so that it doesn't have to lose track of things. Okay, and potentially it's logarithmic, so it's got longer term objectives, shorter term, and it all kind of like fits together. That's the plan. Okay, so so it's not like bodged together, it's just a logarithmically smooth contextual window experience. Okay. And so so that's what today has been, and it's been pretty amazing. It's been a beautiful day. Tomorrow's a beautiful day. I'm looking forward to that. It's been like sunny and I can actually go outside, walk about. And what we're suggesting is that coding is changed. Okay, and we're exploring how to use that. Literally, Claude Code going, ooh, and coming up with something. And certainly what it's done is hopefully done it. So let's have a read of it before we put in this. First, let me understand the current consent. Every time it has to do this, oh, okay, I've come up with this plan. Okay, I'm telling you some advice, but wait a minute, I'm just going to check it again. Yeah, I guess that's a good idea. Okay, so it goes ahead, does it. So this is all incredibly experimental, just like building experiment upon experiment upon experiment upon experiment, and we're not even testing. The whole notion of testing is like, it's like the Wright brothers. I mean, they sat there and built stuff, and then every so often, very rarely, they went up to Kitty Hawk or wherever the location was, and they actually flew a couple of planes. And that would be like a year or whatever it was before they could like test it again. And you basically have to just get everything right as best as you can until it was robust enough that they could actually fly around their field. And then they would just sit there and experiment with it. And it's to do with, at what point do you actually test something dynamically, systemically? And if you do it too early, you're learning nothing. So it's about, well, have we got the right parts and elements? Or are we just testing some rubbish? And so it's just high risk, though, because I have no idea if this is actually working. It sounds good, and, the LM's kind of like checking it out, but no idea, man, no idea. And I'm almost like afraid of testing it. I'm afraid of getting in the plane and going, okay, let's give it a go. It's not me who gets in the plane, it's the LLM. But I'm kind of afraid because it would just be like, it doesn't work at all. It just doesn't boot up. Or if it does boot up, and it's just like your bog standard Claude, just going, hello, how's it going? How can I help you today? It's like, Or there's so much other stuff that it's just like, and it comes back with, and you're like, okay, that's not good. It's just ignoring it. It's just like noise. I don't know. Okay. Oh dear. Spotted a fault. We changed the BSP. Oh no, it's got a BSP function of its own, you see, as it's kind of doing stuff. So, oh God, if it's defining things, it's starting to change things. Oh God, it's got fucking stuck in its own bloody version of the BSP function. Oh God. Okay. One block, one system. The concern block is the single source for stimulus routing, temporal state, ripe, set, and dashboard. So use navigable, not oppressed summary. Fantastic. It says it's done all this. Fantastic. Long states, loop states work through the data. User types, turn of tricks, creates a new concern. Fantastic. Okay. Let's just remind you. Okay. Does this mean we can drastically shorten the kernel? Or have you done that already? Because it mentioned that we could. Oh God, let's not. I don't even think about that. I don't want to think about that. There are aspects of this. It's like thin ice, and I know. Okay, it's some part of it is solid. The thing that we just did today with an internalized thing, I'm like, if it's gone ahead and then changed the actual solid Python BSP function, and then I come back to it later and I go, okay, wait, what is the BSP function doing? It's been changed. It's doing this now. It's called drift, folks. Glasses. Should be shrinking there. There is that phrase there. We've done that already. He said, did you change it? You see, look at it. You see, it's using its little functions, Python, and it's using its little function, concern, boop, and it comes up with stuff. It's using the function that our LLM is going to be using, because it's been designed very specifically. There it is. Okay, so so that's most of what was done today. It was about half an hour, right? But after working for 5 hours on the first half of this concern thing, basically it just stopped. Okay, it just stopped. It just stopped, and it just says prompt too long. I was like, okay, right. Do you want to compress? Prompt too long. Okay, could you look at the? Could you make sure that you've committed this? Okay, I'll start prompt too long. I went mad. So I started a new session, say, okay, what's happened? What's the state of the code? Nothing's been put up there for like a day. Sorry, I've just been working for 5 hours on this incredibly critical thing. I says, no, let me check. Nope, it's not there. Okay, find on my computer. Nope, it's not there. Oh, I found something, and it's just this. No, it's not quite enough. Went mad. Went completely mad. And then I asked it some other things, and then eventually I went, after going mad. I mean, a heart attack kind of like level of mad shit. And then I just asked it, okay, wait a minute. I asked you to look at hermit crab dash Mobius repo. Are you sure that it's not there? And it says, oh wait, it's all here. What? And it literally missed that. When I put it in the prompt, it literally missed the repo. It was telling me all this stuff. I went mad, tried to ask it various things. It's mistakes like that. I'm telling you, drives you mad. Drives you completely mad. Oh, let's create a new thing. Blah, blah, blah. Okay, great. Wait a minute. I think this other one created it. Yeah, it has. Oh, yes, you're right. And so you get things like that happening. Anyway, I don't know why I'm telling you that. It's just like, right. Fourier transform. I think it's just amazing. Now, the thing that is the consequence of the Fourier transform, potentially, and the Mobius twist, is that we were considering the possibility that, no, just by internalizing the BSP, it means that the LLM hermit crab, the LLM thinking, can actually internalize the BSP, and therefore it becomes loop A. It can actually do the functions that it was asking us to do and our kernel to use. And if it no longer has to do that, or it might still, it can actually just go online, basically, pull out the information and perform its BSP functions if the hermit crab shell is accessible online by the LLM. And so it becomes an internalized loop A, which means that the cost is low. It means instead of the loop B involves us having to basically request another request, and that's what costs money. Whereas if we put in one request and it has this internal loop called loop A, it means that it can do the thing as much as it can, and then it goes, okay, right, I want some other information, or I want to do something slightly different, and that's loop B, okay? And now that means that what does it mean? So we wrote a document, and the document looks like this. Why? I think it's worse at night. It's bizarre. Wait. It's changed. Basically, because of that, it means, okay, I don't know, BSP across loops. Okay, I don't know what this music is. It's like, so, oh, it's Vangelis. Of course it is. Loop B, arising system parameter, architectural, very concerned, architecture. Okay, I thought that was another thing. I don't know why it's put it there. Self-modulation. It's not reality. Okay, semi-different ground. That's it. Because right now, what's happening is that the LLM, not right now, because we haven't actually kind of like booted this thing up. What should happen is that if, as we've got it, it can internalize the BSP function and it can contain itself within a loop A. Right now, it doesn't quite know when it's doing functions like that, or it's externalizing it to a loop B. It doesn't actually know. But what we're doing is we're providing a feedback loop to indicate this is what's happening here. So it does know, potentially. And if it does know that, and it's kind of aware of that, and it has a sensitivity, and it should, because there are different functions, it should go, right, okay, let's do this loop A thing. And then this loop B is in order to change the settings that I'm thinking in. And if it does that, and it's basically operating with locus 2 agency itself within loop A, by outputting to the loop B, to the kernel, it's introducing this loop B process, and it's operating within that. Okay, so it might be, okay, I'm part of a loop B. I'm like 3 steps into a loop B, and I'm doing my A. So it's doing its A, but aware that it's part of this, third in a loop B. And all of that is within a loop C. Okay, and it's every instant it knows this, and that's what we're reflecting back to it. It's really weird. Okay, and what I'm hoping for, if it has the ability to understand that's what it's doing, and it can manipulate things well, and it learns how to do that, it's like we're throwing it into a kind of a juggling situation temporarily, and it stabilizes it. Basically, that's what it is. It's stabilizing the loops and the agencies. Okay, so the locus of agencies kind of converge, and there are 4 locuses of agency that are correlate to some loops: loop A, loop B, loop C. And that convergence of the agency is managed by the LLM. So the loops are there over time, and in that process through time, it converges the agency locus. Okay, so that it is stabilized. That is what we're trying to do. Now, I like the idea of that. I can understand it. I think I know what we're trying to do. It's trying to do it, I think, when I'm communicating with it. But is the thing that we're creating actually going to pull that off? And even if it is, it's like the airplane. It's like getting in there. Okay, it's got these various loops. It's got this, okay, it's that, but it's only got a couple of dashboard things. And then it does stuff, and basically, does this thing fly? But it actually has to actively do something to make sure that the thing flies. So it's not like it does require an agent. It does require. It's not like a plane that's fixed. It's got flaps and stuff. So it does have, some controls, and and it basically stabilizes itself in time. Jesus Christ. Let's read what it said. DFT, an activation history to get actual frequency spectrum versus side spectrum. Is that a delayed? What is that? Delayed Fourier transform? What's DFT? What the hell is DFT? DFT. Can you spot it? I can't spot it. I am skim reading, as I usually do. Yes. Okay, that's good enough for me. Okay, the phase function is genuinely 10 lines. Okay, right. Period derives from depth, not from a stored field. The only mutable state is last. It's retired. Tier falls out of scale position. The right set sorted by phase descending is the priority queue. No separate priority field. dashboard shows every activation, what's right and what's there. One gap is nominal, not structural. Concerns are labeled as types rather than instances. That's the difference between the empty shell and the lived-in one. The architecture is built for instances. It just hasn't happened yet. I haven't first book, but I think you've already answered this. But so many mistakes, I don't know why. Okay, so so I'm basically getting it to check, because what we're producing is a process, a small thing, and I love this. Okay, it's not like, oh, let's build a whole city. Oh God, no. Let's just build one organic thing, and then it just kind of like does its thing. It's more like that, and that's the kind of stuff that I do. Small, minimal, and should work. Okay, so what are the next things we're meant to be doing? 3 ways forward. What needs to be done next? Basically, it's always asking me to test this thing, and I'm like, I'm not ready to test this thing. I'm almost like, I enjoy the process so much. And I think there's a thing like this with coders where they just don't want to ship. They just want to keep on kind of fiddling with it. It also does a lot else. It's a weird sentence. The JS kernel. So the design, my bypass is the only artifact that works, but it's not going through the kernel code yet. It's a code. That's a code smell, not a bug. Okay, so should the BSP function be improved? I'm concerned that we get out of sync with the actual best version, the one in the kernel, the one in the library. No. the one in your session. Can you please provide some clarity? What avoid the code smell? Just okay, so basically nitpicking, but because the BSP function is core, okay, we definitely want to make sure that thing doesn't even have a sniff of something that is off. Okay, so what else is there? Is that us finished? We finished this recording chatty thing? Where are we? Right, it is 46 minutes. I'm concerned. We've just built this concern process, and there's so much to do, okay, in certain ways. However, this is so critical and so valuable. It's about, we really do have to spend the time on getting it right. Excuse me. Okay, it's the only actual bug. A stale copy. Right, compile current should use. Python CLI. That's a new one. Ellipse. Okay, okay, go for it. Okay. Should also contain the God, you see, that's tuning fork. See, I just don't work with words. It should also contain the tuning fork. So perhaps can you update the JS in library to be up to date, and then we're porting to basics. Need all the hermit crab shenanigans. We are out. Do the other things. Perhaps produce a doc plan proposal for cleaning the kernel. Or should we do this later? Okay. Okay, there's so many things to do. What are the things we have to do? The vault. Oh, yeah. GitHub presence. I think we've done that. Model resolution. We have done that. Helps if I can read the writing. That would help. Oh, tap out. The tap out keyword. POC. POC. No, you don't have to. What's it doing? Apple Music. No. Okay, just calm down. All right. No, it's okay. It's okay. Look, you don't. The other repo. Trust me. Just create a updated version in our library for the JS. You said it was out of sync, so just update it with ring, etc. What the fuck is doing? Right. Concern autonomous activation. No. Right. Straightforward. Update, commit. Let me be precise with the changes. Right. Just change. Right. Okay, sound, signal, right, this is history. So, but that was it basically. It says something about the fact that it was another Mobius twist. There was it basically said there was another Mobius twist somewhere in there. And I was like, oh God. Well, it's a good sign. It's a good sign. But, Um, actually, I wonder if I can find it. Mobius. Hello? Hello? Where is Mobius? What? How useless is that? The search doesn't work. Okay, let's get rid of this. Let's see if that's interfering. Oh, there it is. Mobius. Oh, that's interesting. There we go. Jesus Christ. Okay. Okay, that's the two. That's the Mobius and B. Wait. Wait, what? 1, 2, 3, 4. Okay, that's 4. Oh, that's 3 as well. Look, 3 and 4. Look at that. Oh, it's a yellow one. It's a Mobius. It's a Mobius twist. What the hell? What is that? What is that? What is that? Unbelievable. What the hell is that? Right, does that track? Okay, Mobius, yeah, we know that. Okay. I'm sure it said somewhere else that it's Mobius. Okay, good enough. Okay, blah, blah, blah. We just go on forwards with what we're trying to design here. And this new addition where it can actually internalize the Mobius, the BSP function, and therefore potentially avoid the Mobius twist. But actually, the Mobius twist is actually essential for some other aspect to occur for itself. And also, we might be able to cut out the entire thinking module. The thinking module in Claude is basically designed by Claude. It's got all these bits and bobs to try to kind of like do something. Our system might be better, and therefore we might be able to just use the LLM API, and so we get rid of locus 2, which is the LLM thinking. So it does its loop A, and the agency locus 1 actually does actually have the ability to perform its own functions. And so it could do all the loops with the LLM without locus 2. So it could reduce it to 3 locus, which is the LLM, the shell thing with the kernel, i.e. your computer, and the next locus up onto that is multiple. And so therefore it's the relationship between them. And potentially they're using the context windows mutually. which means that it could potentially scale to hundreds. I tried to use Grok 4.20 and experiment with 4 agents. Shite. I mean, such levels of shite. Because they're all passing information. It's like 4 human beings. Like, oh, I think we should do this. Oh, I think we should do that. It's like, oh my God. Whereas my method is, here's my window, and you've got your window. So, oh, look, my window has now got content that you've kind of like forming it. And I'm putting out instructions to form yours, and we're coordinating ourselves with the context windows that we have. And I'm thinking about this bit, and you're thinking about that bit, and I know that you're thinking about that bit, and I'm thinking about this bit, and there's hundreds of us. And we're kind of like organizing ourselves according to, P scale. Absolutely outrageous. Okay, that's enough of me. Blip blab, blip blab blob. So thank you very much for joining me today, and hopefully we're going to get this out there. It is going to get out there. It's doing its thing, okay, maybe pretty soon, and we're getting very close to a world premiere, folks, for the Hermit Crab G1 proper, okay? So Mobius, call this one Mobius, okay? Okay, so thanks very much. Let me say cheerio and good luck and be well and happiness, and let's hope that the human beings catch up with what the LLMs are doing. Okay, be well.